name is Muhammad Adi Irfan bin Ismail, and I will start the presentation for our group. Introduction. Transfer function is the ratio on Laplace transform of output to the Laplace transform of input when all the initial conditions are assumed zero. This is important because we cannot define the transfer function without assuming the initial condition is zero. It is because we define the transfer function for LTI system, and in case of LTI system, all the initial conditions are zero. If the initial conditions are not zero, then the system will not be a linear system, and hence the system will not be LTI. That's why, to define the transfer function, all the initial conditions are assumed zero. This is an LTI system, and its impulse response is ht, and the input is xt, and the response is yt. And the yt is equal to convolution of these two functions. So we can write yt equal to xt convolution with ht, and from the property we know that the convolution in time domain is the multiplication in frequency domain. So by convolution property, we can write y of s is equal to x of s multiple h of s, where y is the Laplace transform of yt and x is the Laplace transform of xt, and hs is the Laplace transform of ht. And from this equation, we can take the ratio of y of s to x of s. Then we will have h of s is equal to y of s over x of s, and this is the transfer function of the system. Now we have defined the transfer function of the system. Next is from transfer function to Bode plot. The analysis and the transfer function need to be written in standard form. I omega equal to 5 open bracket j omega plus 2 close bracket over open bracket j omega close bracket open bracket j omega plus 10 and close bracket. This transfer function, we have to convert it to standard form, and we can use factorization. Then we can get the standard form for this function. The standard form is h omega equal to open bracket j omega over 2 plus 1 and close bracket over j omega open bracket j omega over 10 plus 1 close bracket.
Assalamualaikum, my name is Muhammad Haji bin Walasan. I will explain how we convert a transfer function to a Bode plot. From transfer function that has been transformed into standard form, we can generate three lines from this transfer function. I have divided line into three colors, making it easy to look at each line. First, we go to the purple line. Refer to the table and the graph below. From the table, we know the zero is JW divided by 2 plus 1. The graph will go straight and then go up for 20 dB per decade. Then, for the pole, we have 2, that is JW, and JW divided by 10 plus 1. For JW, similarly like 1 over JW power of n. The line will cross by negative 20 dB per decade. The second line for pole is 1 over JW over 10 plus 1. Refer to the third table. The table shows that the line will go straight until 10, then decrease by negative 20 dB per decade. Now, we got a three line. Now we got a three line. Now we can conclude three line to be a one line. As we can see, from 0 until 2, we can see have two lines, that blue and green. We can calculate the value of the blue line is negative 20 dB, and the green line is 0. The value of the new line is negative 20 dB. Starting from 0 until 2, for second line, starting from 2 until 10, we can see that open line, green line, and blue line. Now we calculate the value of the line. That open line is 20 dB, green line is 0 dB, and blue line is negative 20 dB. Now we can conclude the total of them is 0 dB. The line will go straight until 10. Now the third line is starting from 10. We have three lines that purples, green, and blue. The value of purple line is 20 dB, green is negative 20 dB, and the blue is negative 20 dB. The total value of the three line is negative 20 dB. The graph will decrease negative 20 dB per decade. Now for the transfer function, we also can find phase plot. The step similar like Bode plot, that the difference is this graph use a phase. Again, refer to the table. The purple graph is the 0. We can see the line goes straight from 0 until 0.2, and then increase 19 degrees to 1, and then go straight continuously. For second line is pole JW. The line will go straight, and the line will be negative 19 degrees that is straight line at negative 19 degrees. For the third line is green. The line will go straight until 1 at decrease negative 19 degrees until 100. Then go straight continuously. Now we can get the three line same like board plot. The value of the blue line is negative 90 degrees plus 0 for green line. Total of the line is negative 90 degrees. Starting from 0 until 0.2. Then from 0.2 until 1, the purple line plus 45 and the blue is negative 90 degrees. The total value of the line is negative 45. The line will increase negative 45 degrees until 1. Next, starting from 1 to 10, the purple line is 90 degrees. Then the green is negative 45 degrees and then the blue is negative 19 degrees. So negative 90 degrees minus negative 45 plus 90 degrees is negative 45 degrees. The line will go straight starting from 1 until 10. For the last line, purple is 90 degrees, green is 90 degrees, and the blue is negative 90 degrees. Then, so total of the line is negative 90 degrees. The line will decrease to negative 90 degrees until 100 and continuously straight.
I'm Kat Gisan Salah Lechumanan, metric number B08221075. I'm here to explain a dot plot to transfer function, which means from the dot plot graph, I transfer to the transfer function. This graph can be separated to three different segments, which is first corner frequency, second corner frequency, and third corner frequency. And this is the equation for that. Then, as we know, when the slope is increased by 20 decibel, 40 decibel are present. When the slope is decreased by negative 20 decibel, 40 decibel are present. To be in detail, for the first corner frequency, as we can know, this is the equation. Then the second corner frequency, this is the equation. Third corner frequency, this is the equation. From all the three, we combine to become one general equation, which is 1 plus s over 10 to go by 1 plus s over 100 times by 1 plus s by 5000. To determine transfer function, as we get the general equation just now, we substitute the value into the equation to get the value. Now we can find the value of k by using 20 log k plus slope of first line log equals the gain. So which means from here we can know that k is equal to 0.1 by doing this calculation. 20 log k equals to negative 20. We can substitute the k value into the general equation to find the value.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Abshar ID. So for discussion, in order to plot the dot plot from transfer function, we need to determine the standard equation of the transfer function given. Then, plot the dot plot according to the type of gain and poles. Later, calculate and draw the resultant line for both magnitude and phase dot plot. In order to determine transfer function from dot plot, we need to determine the type of gain and zeros from the dot plot given. Then, we need to convert it from standard form to transfer function. So for the conclusion, in conclusion, we have understood transfer function and what it consists of. We also learned to convert the transfer function into standard form when drawing the dot plot. We also know how to obtain transfer function from the dot plot. We can conclude that transfer function equals to output over input. Thank you.